Welcome, I'm Tim Hales. In this, the third of our series of 6 training videos, I will introduce the user screens for our intro guidance system. First, you need to power up by pressing and holding the button until the LED lights up. You then need to wait a minute or so whilst the PC inside boots up. Once this is done, it will automatically go into the home screen. The touch buttons on the right reflect the options available. For an Intero machine, the top button will be the Intero symbol. If the machine can perform additional functions, for example within row weeding, there will be additional buttons with extra application mode symbols. Below the Intero symbol is the Configuration Editor button. You do not need to access the editor in normal running. More on that in Training Video 6. Below that is the Service Tools button, which gives you access to a variety of tools that can be useful in maintaining or fault finding a system. This will be covered in Training Video 5. Finally, at the bottom is the Power Down touchscreen button. To start Intero guidance, touch the crop row symbol button. The button will go brighter and the function actioned as your finger is removed. You will be taken directly to the Intero guidance working screen. Note, it is possible to select your own home screen background image. It is also possible to customize button color and to insert branding into both home and working screens. This is the working screen. It features a live image with template and tracking crosses overlaid. A green dot or green chevrons below the image indicate side shift or disc steer position. A red chevron with a vertical bar indicates the limit of travel has been reached. This should not be allowed to occur for extended periods. A fine offset gauge on the right shows the amount of left or right bias set by the user. This can compensate for minor lateral camera misalignment or side slopes. By default, the fine offset has 6 1 cm steps in either direction, though the number and size of steps can be configurable. A speed gauge on the right displays forward speed, which should match the tractor speed. By default, the speed bar is green up to 11 km an hour and red over 15 km an hour, which is normally a sensible operating limit, though guidance will continue at higher speeds. An image quality gauge to the left of the screen gives a relative indication of likely tracking performance. The higher the green bar, the better. A low bar indicates either a poor template match or poorly defined crop rows. Guidance will, under most circumstances, operate down to an indication of approximately 20%. Towards the bottom left corner is an area reserved for warning and system status symbols. An implement lift symbol is displayed when a lift signal is received. A circular red brake symbol is displayed if the implement is down but not moving. A warning triangle indicating poor tracking is displayed if estimated lateral error exceeds 25 mm. On seeing this warning, users should check performance on the ground. If enabled, the warning triangle will be accompanied by an audible warning. The area below, at the very bottom left of the screen, is reserved for warning messages related to potential hardware failures. For example, a red thermometer and computer chip symbol would indicate that the console computer is overheating. This may indicate an internal hardware fault, or the console should be mounted in a way that improves cooling. The lightning symbol with a broken link indicates that the steering valve output is open circuit. This may be caused by a connector becoming disconnected or the wire may have been broken. The lightning symbol with radial yellow lines indicates that the steering valve output is short circuit, suggesting damage to the wiring. The CAN warning triangle indicates a CAN communication failure, suggesting perhaps damage to the CAN wiring. Hopefully you'll never see these messages, but if you do, they can be very helpful when fault finding. Finally, there are 3 optional features that may or may not be enabled. 2 are indicated by symbols immediately to the right of the image quality bar. 1 is a coloured plant symbol indicating that some colour choice options have been enabled, which can be altered by touching the plant symbol. The second is a light bulb symbol indicating that lights are fitted. Touching on the symbol turns the lights on and changes the symbol to a yellow colour. Touching again turns the lights off. The third option is a fine offset tool that adds a flip touch button under the fine offset bar, which when touched flips between the 2 different fine offset values. This is useful whenever bias regularly alternates between 2 states. For example, working on side slopes or in tall crops blown by a crosswind. Where multiple cameras are fitted, each will have a live video thumbnail at the top of the screen. Briefly touching on a thumbnail selects that image for the main display. Alternatively, you can use the button labelled with a multiple camera graphic to toggle between the thumbnails. Briefly touching on the main video images switches to a full screen video mode. Guidance continues in this mode, but the information symbols, speed, position indicator, etc. are obscured. Touching again reverts to the normal size image. Touching and holding on an image or its thumbnail stops images from that camera being used for guidance, making guidance solely reliant on any remaining cameras. When a camera is disabled in this way, a red cross is superimposed over the image which remains live. Touching and holding again restores the normal function. Touching on the spanner button at the top right takes you to the setup screen. Navigation in the setup screen uses the arrow keys on the right of the screen to move the cursor. When the cursor is over this item, it is selected and the text turns white. On the first line, you can set the crop height, selecting from small, medium or large. You can also select from preloaded crop and machine geometries to match your current job configuration. You can have several preset geometries stored as configurations, so it is not necessary to adjust row spacing or camera height values between jobs, as these can be pre-entered and the appropriate one quickly selected in the field by simply moving the cursor over it. Preset crop and camera information for that selected configuration is displayed below. You can use these figures to check that the selected configuration matches your crop row spacing and camera geometry. If you do not already have a configuration file to match the situation, we will show you in video 6 how to create one that does. If crop color choice has been enabled, you will see an additional line offering alternative color strategies. In the vast majority of cases, conventional green will offer the best performance. Other color choices should only be selected if green will definitely not work. Examples where other color choices may help include red for red lettuce varieties, the green and red option for red lettuce varieties that have a green growing point in the center, or custom color adjusted slightly towards the blue. For example, a color value of about 30 for some allium and brassica crops. In general, there is more scope for incorrect color choices to degrade performance than for correct color choices to improve it. so great caution should be exercised. Now to reach the advanced setting page, touch the top right spanner ++ button. This screen provides system information, diagnostic tests, and options to change more advanced settings. Information includes software versions, total running time and area covered since new, a resettable time and area meter. You can select between imperial and metric units and view, and if necessary, reset learned parameters such as camera skew and camera offset. These are figures our system has automatically learned relating to camera misalignment. Camera skew is angular misalignment in the horizontal plane which is learned during initial running or after skew has been reset. It compensates for minor misalignment up to 3 degrees. It has been greatly exaggerated in this slide for illustration. It converges to a stable value after 100 meters of running. It is good practice to make this initial run-in in a flat field on crop with well-defined crop rows so that the value learned is as accurate as possible. Automatically learning camera alignment to high precision in this way increases acceptable mechanical tolerances without sacrificing tracking performance. However, a camera skew greater than 3 degrees is not acceptable, and its causes should be investigated. If a machine has multiple cameras, each camera will learn its own skew value. For machines with multiple cameras, the offset parameter is the lateral misalignment from the left-hand camera, and any other cameras mounted on the same section. The left-hand camera defines the datum, and other cameras use that to calculate offset. Like skew, it is learned in the first few meters of running and converges to a stable value after about 100 meters. The learned parameters should only be reset if you have made mechanical changes that may have affected the values. Also available from this page is the steering test, an interactive test that checks position sensor and hydraulic flow polarity. It also checks the lateral speed and will report if that is too fast or too slow, as well as reporting if full movement cannot be achieved. Once initiated, you simply follow the on-screen instructions. If proportional valves are fitted, the same test is performed, but with 2 additional full stroke movements to calibrate lateral speed. From the screen, it is also possible to enable some optional features and to change some behaviours. There is a buzzer in the console, which can be set to sound an audible warning if the tracking warning is displayed. The default is on. You can also change how the system responds to various situations. If you go into manual guidance mode, from the working screen, our system will, by default, stay in the manual guidance mode when it starts moving. However, you can change this so that it automatically reverts to vision guidance mode once it starts moving. By default, our system will always try to find the rows to follow, no matter how difficult that is. This policy can allow guidance to continue in some surprisingly difficult situations. However, some users prefer for our system to give up somewhat earlier so that they can deal with the situation manually. This option enables that behaviour. By default, our system stays in the current position when it goes into manual mode. However, users can use this option to force a side shift to automatically centralize in that situation. If a machine will be regularly used on side slopes, or will work with tool crops that might be biased to one side by crosswinds, then it will be worth enabling the fine offset flip option. As we saw in the earlier slide, that adds a touch button to the working screen below the fine offset bar that enables drivers to flip between the 2 fine offset values. The penultimate item gives you the option to view the error log. The last item gives the version of firmware load on the Implement Modules microcontroller. The system may retain its settings if the power is interrupted, but like any computer, it is much safer to power down properly. From any of the setup screens, press the loop back button to return to the working screen. From the working screen, press the bottom right home button to return to the home screen from where you can. Press the bottom right power down button, saving all settings and logs from that session, so that on restarting, you will be able to carry on with exactly the same settings. We hope you found this presentation useful. Remember that this is part of a series of 6 videos that you can select from our website and view as many times as you want. Our website also has links to other reference and training material, including full reference manuals in English, Spanish, French and German languages. If you have any questions, please get in touch. Thanks for watching.